So in chapter 4, we're going to begin the integral section. First, let's kind of look at this question. If f prime is equal to 2, that is the derivative is equal to 2, then can you guess what the original function is? So what you're doing, you're trying to guess, what would the function have to have been in order for me to get a 2 when I take a derivative? So this one is pretty easy. It's going to be 2x, right? But it could be 2x plus 1 or 2x plus 2, because if you were to take the derivative of 2x plus 1, the derivative of 1 is 0. So 2x plus 1 or 2x plus 2 both give you a derivative of 2. Therefore, we kind of know that the original function would have to have been 2x, but we don't know what you could have added after that, as in the number after that. And so when we write this, we write a plus c. C means a constant. So we don't know what it is after that you could have added to the original function to get that derivative. So we put a plus c as like a placeholder. So this is what we're going to do for the entire chapter 4 and so on. So there's another name for integral, and that is called the antiderivative. And so they mean the same thing. So this is the integral of a function. Another way to say all of this is differential equation, or DE for short. So this means an equation in x, y, and the derivative of y. So that is y prime. For example, y prime equals 3x, we would call that a differential equation, or something like x squared equals y prime plus 1. That would be an differential equation. So something that has a derivative to it. All right, now we're going to have two kinds of integral. One is called the indefinite integral, and then we also have a definite integral. So we'll probably just do indefinite first and then definite later. Indefinite integral means the antiderivative or integral of a function, but the difference between indefinite and definite is this one is in the general solution. So what does that mean? That means if you were to take the integral of 2x dx, I'll talk about this later. This symbol means integral. It's equal to 2x plus c. The plus c makes it an indefinite integral. All right, and then the last thing definition-wise is the constant of integration. So constant of integration is the constant c that is added at the end of a general solution. All right, so let's go ahead and practice. So for example, the first question says find a general antiderivative to the following questions. And this is a power rule practice, remember plus c. So we already did number 1, but let's just do that again. So if we were to find the antiderivative of g of x, we would write this is the integral, which is the antiderivative of g of x. And when we write something like this, we have to say, kind of like when you're taking derivative, you say, taking the derivative with respect to what? So what is your variable? What's considered your variable? So same thing here, when you're taking the antiderivative, you have to tell them, well, with respect to what? What is your variable? So I'm going to say that x is my variable, so I put a dx there. So you always have to put that part at the end of the integral. So we know that g of x is 2x, so we would just write 2x dx, the integral of 2x dx. We know that this is going to be x squared, but we don't know what kind of constant it could have added to the original function, so we put a plus c. So this is the answer. All right, let's try another one. So this time g of x has a 2x with a x squared plus added to it. So if we were to take the integral of that, we know that the antiderivative of 2x is just x squared. Now, here's how we do this one, or this is how my teacher taught me in high school. So if we were to take the integral of just the x squared part, so what you're going to do is kind of guess what it could have been. Well, I know that in order to get to an x squared, the integral would have to have been a power higher, right? So if you want to get to x squared, the previous function should have been a third degree, right? Every time we take a derivative, the degree goes down by 1, right? Power rule. So if you had the x cubed, the derivative is x squared, and you take another derivative, it's going to be 2x, which is 1 degree less, right? So kind of by that idea, we know that the original function is probably something with the x cubed. So we're going to guess. We're going to do this thing called a guess and check. So we're going to guess that it's going to be x cubed. But since it's a guess, I need to double check my answer. So I'm going to take the derivative there. And then I can see that, oh yeah, I got that x squared. That's good. But I have an extra 3 that I don't want. So what I'm going to do is I'm going to multiply by something on both sides to get rid of that, that 3. I know in order for this right-hand side to look exactly like x squared, I need this 3 gone. So what I'm going to do is multiply by a reciprocal there. And I match it on the left. So 1/3 x cubed is actually the antiderivative of x squared. Let's double check. If I have this function and I'm taking the derivative, I would do 3 times the coefficient and then 1 degree less. That cancels out. I get an x squared. So my guess was correct. It is the antiderivative of x squared is 1/3 x cubed. All right, so I'm going to write 1/3 x cubed here. And don't forget your plus c. All right, let's try another one. So I am going to take the integral of that with respect to x. So integral of something plus something, kind of like what I showed you before. You just take the integral of each one. Okay, integral of e to the x. Remember, the integral of e to the x, or the derivative of e to the x, is just e to the x. Therefore, this is just e to the x. 3x, you have to start guessing. Okay, so how are we going to get to 3x from a previous function? Well, I'm going to start guessing that the previous function should have been probably an x squared. But I'm going to do guess and check. So 2x. Well, that's nice. I got to the x, but I don't want that 2. Instead of the 2, I want a 3. So think about what you're going to multiply on the right to get rid of the 2, but add that 3. So you're going to multiply by 3/2. That way the 2's cancel and the 3 remains. And then put that guess on the left, 3/2. So therefore, the function should have been 3/2 x squared. Don't forget plus c. All right, let's have you try number 4. So you're taking the integral on both sides with respect to x, and then go ahead and write down your answer. All right, the answer is 1/2 x to the 4th plus c. All right, now let's look at some problems that's not just a pure power rule. There are, we're looking at other problems here. So for example, number 1, sine x. What could be the antiderivative of sine x? So kind of think about, when I take a derivative of this, I could get a sine. So what function would that be? Well, that's going to be a cosine, right? If I take the derivative of cosine, I get negative sine. I have a negative there that I don't want. I'm going to multiply by negative here, so that means in the original function, it should have been a negative cosine. And then don't forget plus c. All right. Okay, so let's have you pause the video and practice these. We're gonna skip number 3 because we didn't learn this rule, the log rule, but the other ones we learned, but you have to kind of jog your memory to see if you remember these. So for example, number 6 and number 5, they are special functions that hopefully you remember. If not, you had to look at your derivative rules. So pause the video, give these a try. All right, first, make sure you have plus C on everything. This is very important. That constant has to be there. Next, it's just, whether you remember the function. So 1 over x, the integral is natural log x, but notice how I put an absolute value there, because in the natural log or any kind of log, that x value has to be positive. Okay, and then just looking at the other ones, just whether you remember these functions or not. All right, so now some tips on finding antiderivatives. If you have a radical function, or square root or cube root or something like that, you always should change it to a fractional exponent, because it's just easier to work with powers instead of radicals. Second tip, if you have a fraction, it's easier if you split that fraction up into several fractions so that you can just take the integral of each part. For example, if you have x squared plus 1 over x, you should split it into 2 fractions like so, and then take the derivative. It's much easier. Okay, and then just a reminder, this is not splittable. You can't split it into 2 fractions, so we're gonna learn a different technique to find the derivative integral of this. Number 3, if it's asking for general solution, not particular solution, so that means we're looking for a very, very general solution and they don't tell us the initial condition, don't forget the plus C. This is very important again. All right, so let's go ahead and practice again. For all functions C such that G prime is, find all functions C such that G prime is equal to this very complicated equation here. All right, so find the function G when given G prime. So it's going to tell you to take the integral. So what you're going to do is take the integral. So write it like this. All right, so let's take, dx. Let's take the tips that I have just told you into consideration. First, we're going to split these fractions into several different ones, and then we're going to change this into a fractional exponent, so we are dealing with powers instead of a root. And then we're going to split this into, you can either split it into 3 integrals, or you can just kind of think that's what you're actually doing in your head. So instead of splitting into 3 integrals, I'm just going to write it as 3 fractions. All right, so first part, 2x to the 5th over x, that is 2x to the 4th. Second part, this part here, if you're not really solid on simplifying this, I'll do it on the side. So we're changing this into, first we're simplifying it, and then second we're changing into a power exponent. So we're going to change this first into 1/2. And then we know that if the bases are the same, we can subtract the exponent. So this is negative 1/2 minus 1, so negative 1/2. So this is actually like that. All right. Now take the integral of each part. So the integral of 4 sine x is, make a guess, probably something with a cosine, right? Take the derivative, you get negative sign. I don't want the negative, I want the 4. So I'm going to multiply by negative 4 on both sides. So I know that, probably should move this a little bit. Okay, so this here is negative 4 cosine x. All right, next part, 2x to the 4th. I'm going to make a guess and say that it should have been x to the 5th. Take the derivative, 5x to the 4th. Again, I don't want the 5, I want that 2. So I'm going to multiply by, get rid of the 5, add the 2. So get rid of the 5, add the 2. So this is going to be 2/5 x to the 5th. Next, x to the negative 1/2. All right, so fractional exponents, but still pretty easy. You're going to add a whole 1 to it. So the previous function should have been 1/2. Take the derivative, 1/2 x to the negative 1/2. All right, I want the negative, but not the 1/2. So I'm going to put a negative there, add a 2. Same thing here, so that function should have been negative 2x to the 1/2. And then don't forget your plus c. Okay. All right. All right, we're gonna look at a different question now. Find f if f prime is this. And you have a initial condition. Initial condition means what happens when x is 0. Okay, so when there is an initial condition or any kind of condition is given, that means there is a particular solution. What does that mean? So without this part, you would have a plus c in your answer because you don't know where this function started. But when they give you a condition, any kind of a condition, then what it's saying is that there's actually a value that should have been for c, and you can figure out what c is. So when there is an initial value or initial condition or any kind of condition given, then you need to evaluate c. Okay, so I'm going to show you how to do this. So you're given this derivative, you're going to find the original function, which means we need to take the integral. All right, so kind of split up the integral in your mind. The integral of e to the x is just e to the x. The integral of this thing here is whether you remember this form or not. So this is the inverse tangent function with a 20 next to it. So if you don't remember, let's kind of do a guess and check. So inverse tangent derivative is 1 over 1 plus x squared. I see that I need that 20 there, so I need to multiply 20 on both sides. So the antiderivative is actually e to the x plus 20 inverse tangent x plus c. That should have been the function. However, it tells you that, well, you need to make this function so that when I plug in 0, you should get negative 2. So when I plug in 0, I should get negative 2. So I'm going to evaluate this. And this should equal 2. So then the only variable you're solving for is c. All right, so let's evaluate. E to the 0 is 1. Inverse tangent of 0. All right, so you have to kind of remember this. Inverse tangent means you're putting in an angle. You're putting in a value, and then you're trying to figure out what angle that is. So what angle when you take a tangent of, you get 0. So this requires that you remember your unit circle or just remember the value. So inverse tangent 0 is always 0. So that's gone. Plus c is 2. So c is, this is negative 2. So this is negative 3. So c is negative 3. So then what we want to do is we have a particular solution. So we want to, instead of put a plus c, we figure out what c is. That is minus 3. So we put that into the equation. All right, let's do another one. This one is pretty much the same, but this time they give you second derivative and want you to find the first, the original function. So that means you gotta do integral twice. All right, so let's find the first derivative. So we're going to take the integral of this function. And then this is going to give me the first derivative. So pause the video give this a try. Find the integral of f double prime. All right, the answer is 4x to the third plus 3x squared minus 4x plus c. All right, good. Now we are trying to find the original function, so we need to do this one more time. Okay, so what is the original function? Now, what's going to happen is you're going to have another constant of integration in there, but you cannot call it c again. If you call it c again, you're saying those two numbers are exactly the same. So just give it another letter, maybe d, but you can't call it the same letter again. So go ahead and give this a try. So pause the video, find the original function with a constant of integration. All right, the answer is x to the fourth plus x cubed minus 2x squared plus cx, right? Because the integral of c is just c. C is a constant, so the integral must have been just the constant with a variable plus d. So I have a new variable there. Now, because I'm given two conditions, I can find c and d. So I'm going to use the first condition. When I put in 0, I should get 4. So when I put in 0 for x, to 0 squared plus c times 0 plus d equals 4. So this is very simple. You can see that d is 4. Now that you know d is 4, you're going to use the second condition, which is f of 1 is 1. Okay, so f of 1, that is 1 to the fourth plus 1 to the third minus 2 times 1 squared plus c we don't know times 1, but we know d is 4, and the whole thing must equal 1. All right, evaluate that. 1 plus 1 minus 2, so that cancels out. And then we have a c times 1, which is just c, plus 4 equals 1. So c is negative 3. All right, the last thing we're going to do is plug in everything we know into the original function, which is f of x equals x to the fourth plus x to the third minus 2x squared. C is minus 3, so minus 3x plus 4. Now let's look at some word problems. A particle moves in a straight line so that its acceleration at time t is given by a of t equals 6t plus 4. Its initial velocity is v of 0 equals negative 6 centimeters per second, and its initial position is s of 0 equals 9. Find the position function s. So you are basically given a of t, that is the second derivative of s, and then v of t condition, which is the first derivative. So we're going to have to start from a of t and then take the integral of that. See how I write dt and not dx because the variable is t, so be careful on that. That's going to give me v of t. All right, so let's do that. So integral of 6t plus t dt. All right, again, pause the video, give this a try. All right, this is 3t squared plus 4t plus c. Now, we are given an initial condition at v, so we probably should evaluate this first because this is equal to v of t, right? So we know that v of 0, so when t is 0, so that's 3 times t 0 squared plus 4 times 0 plus c is negative 6. That's very convenient. C is negative 6. So we can be sure that the velocity function is 3t squared plus 4t minus 6. Now, this is good, but they want us to find the position function, so we need to do this one more time. Okay, let's just finish this question together. So we're going to get t cubed plus 2t squared minus 6t plus, I'm going to call it a different variable because I already used c. And then I have to figure out what d is. Now, it tells us that s of 0 is equal to 9. The function I just found is s of t. So then put in 0. I get 0 cubed plus 2 times 0 squared minus 6 times 0 plus d is 9. Therefore, d is 9. All right, so the last thing we're going to do is just plug everything back in. So s of t is equal to t cubed plus 2t squared minus 6t plus 9. All right, last question. All right, a ball is thrown upward with an initial velocity. All right, so we talked about this before, translating these. Initial velocity means when time is 0, the velocity is 64. Feet per second, all right, let's write in the unit, feet per second. From initial height, all right, initial height, s of 0 is 80 feet. Find the position function, so find s of t, giving the height s as a function of time t. One thing, one important part that they should have written in here is that a of t is equal to negative 32 feet per second squared for gravity. So in order to find s of t, you have to start from here, the function. So you can't start from a condition because that's not of t, like any given time t, it's not a function, it's already evaluated. So you have to start from a function, and then that is, you're going to start from acceleration. So give this one a try. You're basically going to take the integral twice and then plug in two initial conditions. All right, go ahead and check your answer. This is the position function. All right, next question. When does the ball hit the ground? When does the ball hit the ground? So you have to think to yourself, what does hitting the ground mean? Hitting the ground means the position will be 0 because it hit the ground. So that means we want, when is this going to equal 0? Now this is not even a calculus question. This is just, this is equal to 0, figuring out when that's going to happen. So you're going to need to factor and solve. So go ahead and factor and solve, and then come back and check your answer. All right, once you solve this question, you should get two t values. One is -1, one is 5. Now, -1 doesn't make any sense. That's before you even, what is this, the context? Okay, the ball is thrown. So it's even before the ball is thrown, so that number doesn't make any sense. So the answer is 5 seconds.